Well, good morning, everybody, and thank you very much for coming out to our talk today. We're going to be presenting breaking access controls with Blekey. And just a quick synopsis of what we're going to talk about is that most access controls really suck. A lot of the systems used for gaining access to buildings, card readers, fobs, they're using very old technology, clear text protocols, and you still find them everywhere, even in modern buildings. And we realized this is an old protocol that no one's really looked at in a while. It would be pretty easy to exploit with modern hardware. So we decided to build something. And what we're going to do is tell you about the tool that we built, Blekey. But before that, we're going to explain sort of the state of RFID access controls, how we use that knowledge to build the tool, how the tool can be used to pull off some physical attacks, and how you can prevent these attacks and help your company or someone you're contracting for deal with preventing this type of thing. So a little bit about us. My name is Evenchick. I'm an embedded systems architect at a new automotive company called Faraday Future. I come from Toronto, Canada, along with my partner here, Mark.
Thanks, Eric. Okay, I'm Mark Baseggio. I'm a managing principal consultant with a company out of the States called Optive. We're from Canada, though. And my team does attack and penetration work. So we do network penetration, social engineering, and, of course, physical audits, physical penetration as well. So a little bit about why or how this talk came about. What you see up here is a big bank in Canada, and also a refinery. And these are two places that you'll find controls like these that control access or are supposed to properly control access. Now, just last month, I was here in Rotterdam. I was at another big company that used these controls. I've been to Asia, all across Asia. You see these controls there as well, and of course, all across North America. So they all use these really vulnerable access controls. And here you see Eric at actually Pearson International Airport in Toronto with a rebadged HID access control system. Now we're picking on HID, but they're the dominant player in the marketplace. As you see, a lot of other companies will rebrand their products, white label them, but there's also other manufacturers that use this same protocol that we're going to be discussing today. So we decided to make the device because, no matter where I went, customers were very surprised when I said, yeah, these don't work right. Basically, this card, I can clone it, Control C, Control V, basically with a $30 cloner off of eBay from Asia. AliExpress is usually the place where we would get those ones. So first, I want to actually tell you a little bit more about how access control systems work. So here's a typical HID reader. And first you have the reader. It sits on the wall, and it sends out RF. And before there's a card present, you have nothing. So the card reader is a bit lonely. It's got no cards. So when we introduce a card to the mix, the card reader energizes the card, and then the card sends out a bit stream that the reader picks up, and is quite happy about. So now that the reader has the data, it has to do something with this data, and here's what we're attacking today. The reader sends the data to a backend or upstream controller, and this is the part that is Wiegand, and this is the part that we exploit, and this is what we're interested in today. So Wiegand is in clear text. It's been around for decades, and I mean since the Apollo 11 era, since we put a man on the moon, we've been using this protocol. We'll go more into the actual protocol a little bit later. First, I'm going to first, this is the whole system kind of in one slide, just in case I went too fast for you there. First, now I'm going to let Eric explain a little bit more about the different reader technologies over the year and how they've evolved and how they all still pretty much use Wiegand.
Okay, thanks. So we showed there's three main parts of these systems. You have the reader, which sits in the middle of a card, and a upstream controller. So there's different things that you can attack here, right? You can attack the communication between the card and the reader and the upstream controller. So we're just going to talk about the readers that have been used and the cards that have been used and what's bad about them. So HID procs is the legacy legacy technology, but you'll still find it all over the place. Again, this exact reader with a different badge on it was at an international airport. You'll see the one on the left all over the place as well. There's also smaller versions of these now. They're very, very cheap, which makes them quite popular. They're about 20 years old. They're resold by other companies, so it might not say HID, but it is. And somebody in this room probably has one of these cards in their pocket. They're just so prevalent for not only offices, but apartment access and really anything you can imagine you're trying to lock down. These are so easy to write that you can buy a $30 tool with two buttons on it. One says copy, so you hold this tool up to a card and you hit the copy button. It beeps. You then take a writable card and hold the tool up to it and hit the paste button, and then you have cloned a card. It's very easy. The cards, they only have 44 bits of data on them, and whenever they send this across to the reader, there's only two supported formats for sending it up to the upstream door controller. Those formats are Wiegand, which is the most prevalent one, and another clear text protocol called clock and data. It's just a different way of putting the same data on two wires. Inside the reader, there's actually just different terminal blocks you plug wires into to choose which protocol. So it's always clear text. There's nothing good going on here security-wise. Some of these have a two-factor authentication. You're looking at the PIN pad here and thinking, well, this is better, because now I need to know both the PIN and have the card. That sounds good. The only problem is that the way that this works is when you push a button, it just sends that number over the clear text Wiegand line. So if you're connected between the reader and the door controller, you're going to be able to get that data anyway. So yes, it is two-factor, but it's very weak. So lots of problems with HID procs. Just everything's unencrypted. So the next step was HID ICLASS. And this did introduce a form of encryption. It used DES, and the encryption is very broken. The reason being that the way that HID did this was they encrypted the data on the cards, and then they used a key, symmetric key inside the reader to decrypt that value. So first off, all the data sent over those Wiegand lines to the controller upstream, it's still clear text. There's no encryption there. It's just between the card and the reader. The second problem is that the key they used was globally the same for all of the readers they sold. And back in 2010, someone by the name of Milos Šmeriak managed to recover that symmetric key by dumping the firmware out of a reader. And of course, once he had the symmetric DES key out of the reader, he could then create cards that looked like valid cards even though they were not. There is a feature called ICLASS Elite, which means you pay more money for it, and you get a unique key to your site. HID manages all of this for you. You can't really have any visibility into that. But still, on that back end, between the reader and the upstream controller, there's still no security. So really, I mean, this seemed good when it came out, but unfortunately, they're still using these terms like enhanced security, mutual authentication, variant encryption today in 2015 on their website, and it's just not true anymore. Like it's been broken for a good number of years. So this brings us to ICLASS SE, which is the newest thing that you can buy from HID today, and it still does Wiegand, and it still does unencrypted Wiegand all these years later, but it supports a new upstream protocol with the help of some additional hardware called Open Supervised Device Protocol, or OSDP. OSDP is a two-way communication. So it's based on RS-485, and it allows not only the reader to talk to the upstream controller, but also the upstream controller to talk to the reader, and that gives you just a lot more things that you can do in terms of securing that exchange. So there is a AES protocol, or a way of using AES over OSDP called Secure Channel Protocol. And if all of these things are implemented, that will give you a secured communication from the reader to the upstream controller. One of the big issues, though, is that we haven't been able to actually buy any of the hardware that does this because it doesn't appear to be available yet. So there are better solutions coming, but I
was on the phone with HID about a month ago, and they admitted that only one manufacturer actually makes a door controller that speaks the protocol. And so you're not going to see a very widespread adoption of this, especially when buildings are usually more than decades old.
Right, and this reader has another issue, which is in very small font. At the bottom, it says multi-class. And this means that this reader will, by default out of the box, read any card technology. So even if somebody's using a much more secure ICLASS SE card, they can still be compromised by somebody coming along with a procs card, which is the old technology that's really easy to read and write, no encryption, putting the right stream of bits on it, and then this reader will just assume it's a valid card because it's designed to be backwards compatible with all these old technologies. So we hope this is a more secure solution, but we haven't actually been able to look at it too much because it's hard to get your hands on. So does anybody use these readers in their office or to get into a building, apartment? There's probably a couple. They're very, very popular in the US. They're somewhat popular here. This building appears to have the ICLASS readers on some of the doors.
It looks like a rebranded ICLASS RW300, which can actually be turned into a writer as well.
So they're all over the place and pretty prevalent. But really what we're talking about is the back end between that reader and the upstream controller. And so Mark's going to take it from here to explain how that protocol works in detail and how we can exploit it.
Thanks, Eric. So John R. Wiegand discovered a wire that was embedded into cards, and these cards were called Wiegand Cards. The cards are very similar to magnetic stripe cards, but they're more durable because the wire was either embedded if there was a 1 in the data stream, or there was a lack of wire for a 0. So it was a series of wires, and as you pulled the card through a reader, you could get the data stream of 1s and 0s. Now, that's Wiegand wire, but the protocol that was used to transmit the data was also called the Wiegand protocol. And so that's where we get the protocol name, but also the limitation on the number of bits that we see on the cards today, 44 bits, which isn't very many. And that's the entire authentication control application is stored in those 44 bits of card data. So it was patented in 1974. And this is where we see, the cycle of a vicious cycle of backwards compatibility. It was put into the product, so people used it. People were using it, so then people continued to use it in the next product. And here we are, 40 years later, and we still have this protocol in our buildings. So I want to show you how easy it is to read Wiegand with modern hardware like an Arduino, which is $20 or so in the States. So what you see here is kind of a facsimile of what you would see in a logic analyzer program. So we have 2 wires, data 0 and data 1 for the Wiegand protocol, and also ground. But for this purposes, we're looking at basically 2 wires. The vertical axis here is volts, so 0 to 5 volts. And the lines on Wiegand are normally held high at 5 volts. When they want to send a bit, they drop the line to 0 volts. And there you go. So if it's on the 0 line, there you have a 0. And if it's on the 1 line, you have a 1. And as time goes on, you just read where 0 volts is, and you've got your bit stream of 44 bits. This, as well as the number of bits in the card format, is all you need to authenticate to one of these readers to send to the back end, and you're in. So here is an actual screenshot of the Wiegand protocol from the Slaley Logic program. And I'll go through it just so you can see visually what a card looks like. So there's the entire, this is a 26-bit card. There's different formats, 26, 32. Some of the cards have 8 bits for the facility code. So its facility code is 0 to 256. And then your card code, which is usually printed on the card, is 0 to 65,500, whatever. So we'll see here. We've got the first 8 bits is a facility code of 21. And then the remainder of the 16 bits, we have a card code of 29,644. So those two things, along with the format of the card, 26 bits, is all we need to get access. So this is when Eric and I started putting our heads together and thinking, wow, let's make a little device so we can put it on the wall and compromise this protocol. So this is a bit of a facepalm as well, and just kind of shows you a little bit of an indication of some of the silliness that goes on in this industry. So this is a dual technology card. So this works with the old readers Eric told you about and the newer ICLASS readers. So it's got 2 physical antennas in there, and it's got 2 chips. And it actually has the same authentication data on both sides of the card. So if I'm, an evil attacker person, I want to get your card access information, I can come by with a reader and read it off your belt, even though your building may just be using encrypted technology. You're still transmitting unencrypted. The other facepalm about this card is that in yellow, you'll see 270. That's the card code, and 05994, that's the facility code. So all the data you need to authenticate is pretty much written right on the card, which is kind of dumb, we think. And so we brought this up to HID, and they say that they're recommending that people use different codes on both sides of the card now for this technology, but it's just something to be aware of that most people are completely oblivious about. As well, with these cards, this is taken from a month ago or 2 months ago from HID's website. You see enhanced privacy, communicates no traceable identifiers during card sessions to prevent card data from being divulged or cloned by unauthorized parties. But we know, given what I just told you, that that's not really true. So it may be true for the encrypted side, which hasn't really been audited properly yet, but it's definitely not for the unencrypted side of the card. So the moral of the story here is that physical access to these readers is winning. Now, we just want to give some people some props. We're not the first people to realize this. This has been around for 20 years, as we've said a number of times. And there's a number of great people on the internet that helped us by, releasing their code. A guy named PageMac has some code on the internet that was the original Arduino code that I used to start decoding Wiegand, and it's still there today if you Google for it. Carl from Procs Clones, another great resource. He's done a lot of stuff with ICLASS, up to completely cloning it, or completely, he's got a piece of hardware that pretends it's an ICLASS card and can dynamically adapt. If you give it information, it will pretend to a reader, and the reader, it looks like an ICLASS card. He's done some really neat stuff. And of course, there's a device called the Gecko, which was presented at 2008 in Black Hat by a gentleman named Zach Franken. Now, it did something very similar. It sat on the Wiegand lines and collected data, but there was no means to retrieve the data other than maybe flashing an LED of the reader, or to automatically, replay the data. So we thought, okay, we're here a number of years later now. We've got this great BLE technology that's, literally $10 a module. Let's make this attack much more practical, so we can walk up with a cell phone to a door and open it, or get the data we need to create a card, to really show clients that, if you really want a secure system, you need to switch away from these. And back to Eric. And
so we built a thing, the BLE key, with a Canadian quarter for scale, but just in case you're not familiar with the Canadian quarter, it's about this big. So that's the actual device that we built there, 18 by 30 millimeters. And Yeah, so it's based mostly on this Nordic NRF 51822 system on chip, which is a really cool chip that you find used in all sorts of peripherals for iPhone and Android, because it has a 2.4 gigahertz radio as well as a Cortex M0 ARM microcontroller, all in the same package. So that one piece of silicon does your Bluetooth and your application logic. We get it in this module format, this red module. And the nice thing about that is it has all the approvals, so we don't have to deal with that, and we don't have to do antenna matching and all those fun things. The other big part of it is this black box down at the bottom. That is an installation displacement connector, or a punch-down connector. And what's convenient about that is to install this device, you really just need a punch-down tool, and you can get the Wiegand wires, place them in, and punch down, and that will make an electrical connection. And it does so without actually breaking the wire. So the reader will continue working just like it was before. Nobody knows that you've done this, but you're now sitting on those Wiegand lines. The other parts of this is really some level shifting logic, crystal to support the module, and some pinouts for doing programming and debugging. Runs on a CR1632 coin cell, so in the back there you just pop in the coin cell. It was developed using some state-of-the-art equipment here. This really isn't hard hardware to develop if you want to get into developing hardware. It's stuff that is relatively inexpensive nowadays. You can get all the tools off suppliers for really reasonable prices, but also you can get the hardware built for really reasonable prices as well. Sites like DigiKey can provide you with every component you could ever need. So we've really reached a point where building this kind of hardware that you're going to embed into a device, maybe years ago that was considered to be something that would be really expensive and really high tech. And sure enough, whenever these devices were originally built and put into buildings, I'm sure that this was beyond the ability of some guys sitting with the beer in someone's house. But nowadays, it's just become so simple with the amount of stuff out there, and it's simple enough that the entire schematic fits onto one slide, which is great. So really, again, it's the module on the left there with a crystal, and the pinouts. The main thing are level shifters, because they actually are just FETs used to pull down those Wiegand wires. So those wires, as we said, they're normally pulled high to 5 volts. We just connect them to ground through a FET there, and that gives us control over the wire. And we also do a little resistive divider so that we can get that 5 volts down to a lower voltage, because the module only takes up to 3.3 volts on its I/O, or else it will not be a Bluetooth module anymore. And then there's just pinouts, an LED. That's all there is to it. It's quite simple. We used KiCad or KiCad to design this, to do the schematic, as well as the PCB. And we actually went through 2 hardware revision versions. First one, which we actually have over here, is significantly larger. It was just done as a V1. We just wanted to get all the components down on the board and test it out and see if it worked. And once that was done, we did another, really just a different PCB layout in order to get it down to the tiny size. And we originally did the assembly of these with a hot air rework station on Mark's kitchen table. It was annoying, but it worked. Mark's much better at the hot air rework than I am. I was just having the components fly all over the place. But once you get the air speed right and you get the solder on there well, you can assemble these by hand. It's just quite frustrating. So we wanted to make a few of them. So we sent a bill of materials and the design files off to a fabrication house, and they came back with fully assembled, individually packaged modules. And for, again, a pretty reasonable price, our BOM cost on these modules is somewhere around $10, which is all right. So we did make a pretty interesting mistake during the development of this, though, and it makes for a good story. When we were doing development, we had like 5 of these things kicking around in Mark's office. And when you're connected to one, you don't necessarily know because they all have the same Bluetooth name. So you'll see BLE key, and you want to know which one is sitting in front of you and which one you're actually working with. So what you do with Bluetooth devices in development, if you've ever developed a Bluetooth device, you've probably given it some random name so that you can tell which one's which. Now what you're supposed to do is when you send the firmware off for manufacturing, you want to switch that name back to the real name of your device. Now Mark was debugging
We didn't have a QA
one.
department, okay?
We didn't have QA. Mark was debugging one, and getting all ready, and he sent the firmware off. It was like last minute. Okay, let's send the firmware off to this board house, who were in China. And they came back with an email that said, we have the update successful, but the BLE name is BLE penis. Now, Mark's company, Optive, actually made 200 of these and gave them out at Black Hat US. And thankfully, we emailed this guy. We were like, no, please, can you update the firmware again? We don't want his company giving these out and everyone, getting them. So thanks to thanks to those guys for solving that. But yeah, once you have it and it has the right Bluetooth name, you can put it in a procs reader. This is actually the reader that we have mounted up there, which we'll be doing some demos on. And it fits in there with like tons of room to spare. You can get the cover back on. No one would ever know that you put it in. It's quite simple. Some other readers, they're quite a bit thinner, but they're often mounted onto junction boxes, so there's often space behind to mount the BLE key. Just depends on exactly what reader you're on. So we decided to do a speed run and see how fast we could do it, and this is that. So I challenged Mark to do it in a minute, and what he's doing now is just taking the top cover off.
This only took 5 takes.
And there's 4 screws. That comes off. So that's the reader there, and this is actually how you'll often see them hooked up. Just 4 wires, power, ground, Wiegand data 1 and Wiegand data 0. And we need 3 of those wires, the Wiegand wires, so 2 of them, as well as ground, because we need to be able to pull the ground. And
they're always the same color, green and white.
Yeah, it's actually labeled right on that white piece of plastic, like Wiegand data 0, green. It's quite convenient. So he puts all those in, punches down. So yeah, the real key with the punch down connector is you don't have to cut, you don't have to splice, you just hit it with the tool. And that goes in, and he did it in a minute. And then the door still works, is sort of the purpose of that. And in this case, we were using a phone, and now we can replay cards. But we'll show this live here. I'll let him do it until the door opens. No card, and send, and the door opens. So once that device is in there, now that we've shown how to get it in, you're probably wondering what the point was. And that's why we'll go through a few different attacks that you can do once the device has been put in. And Mark's going to sort of do the demonstration. I'm going to talk through what he's doing. So the first thing is quite simple. It's recording the card data. So what we're going to do for this is a situation where we have a person named Alice. She has a legitimate card. She's going to tap that card on the reader. Eve, though, has already installed this BLE key, and so Eve is going to be able to recover that data over Bluetooth. Once Eve has that string of bits, she'll be able to actually create a cloned card that is going to look exactly like Alice's, and nobody can tell the difference. So first thing to show here, we have to...
So we have a serial terminal. It's not normally hooked up to a serial terminal, but for the purposes of this event, we thought it would be useful to show you kind of some debug output that we use while we were developing. So Eric's switching to that right now, and there you go.
So the output that we see here is, we received 36 bytes. There it is as binary, and it got cut off there. There's too much text, and we received another card. It's a 26 26-bit card, and there's the raw and data as hex from that bit stream. So again, this was just sort of used in debugging, so we could see, oh, we got a card, here's the bits. But it's less interesting to do that when the device is in a reader, because odds are you can't connect a serial terminal when you want to get the data out. So we did some Bluetooth stuff. So this utility is going to allow us to do the same stuff over Bluetooth. I don't know if we're connected.
We are.
We are connected?
Yeah, so this is a Python utility. Just uses the Linux GAT tools. It's a wrapper because there's no really good Python module for this, but so it's a little bit kludge. But nonetheless, it works, and we're not going to be demoing with a phone today because it's a bit crazy with all of the Fitbits and whatnot in the audience to try to do that. So we have a whitelist, and we're only connecting with my computer.
So the read card demonstration is really simple. We've read a few cards while we were setting this up. And it does take a minute to do it, but there's all those numbers. And if you grab that procs mark tool over there, that tool there, with one of those and that number, you'll be able to clone all those cards. Doesn't matter if they're ICLASS or procs, because the encryption is broken on ICLASS, so you can just encrypt the number and do it again. And that's the first really simple, obvious attack that you can do. The next one is replaying. So this is a situation where somebody with a valid card, Alice used her card, and the door's been opened. She goes in. And then Eve is trying to tailgate, but maybe the company is good about tailgating policies, so you can't just walk through the door. So the door's locked, but that doesn't matter because using a Bluetooth request, which is TX, I believe, we can just open the door. This can be done from a phone. It can be done from an Apple Watch, though we need to make that client work. Anything that can talk Bluetooth, low energy, can just ask the door to send, or ask the last card to be sent, and the door pops open. So these are the two really obvious things. It's, you can clone people's credentials, and you can just walk into the facility. Already, it's like, okay, these are not highly secure ways of locking down your building. But we wanted to have more fun, and we realized that we were connected to these Wiegand lines, and because they're normally pulled high, if we just pulled them low all the time, nobody could unlock the door, not even the real reader. And that seemed like a fun idea. So in this case, you're going to have your attacker, Eve, here, who's going to use a control card, so a card with a predefined number. This one is OX dead beef. And whenever that happens, the BLE key in the device is first going to replay on Wiegand the last valid card, and then it's also going to pull both lines low. And at that point, there's no getting in. So we're going to show this one. This is
the other tab. Just go back.
Oh yeah, I want this tab.
There you go.
So this is started by the control card Mark has there. And it's going to say 20 seconds. And now even with, it opens once. There we go. Now it's locked out, and even with a valid card, there's no getting in, so now you can run around the building and, I don't know, steal some servers or whatever you want to do. Is it practical? I mean, it would be kind of funny, because people would have to go get the hard key for that door, and that could take them quite a while in some facilities. So those are the...
I like to wave at customers through their server room window.
Those are the simple attacks there. I'm just going to switch this back.
Can I ask a question?
Yeah, absolutely.
How do you run it on one button cell?
Right now, it's he asked how long the battery lasts, basically. So right now, it's about 2 to 3 days. There's absolutely no energy optimization to our code because we wanted to get it ready for the presentation. But it could feasibly go to 30 days or even 3 months with this coin cell. Yeah,
we've seen there are devices that use the same hardware running for 3 months on a coin cell.
This is
just
the
a matter
battery.
of optimization. If it's all right, if we can just get through and do save questions at the end, unless something's really relevant to this. So the last attack type that we looked at was the skimmer. And this is something that Mark's actually done a whole bunch on sites. and it works really well. Basically, you get yourself a maxi procs reader, which is the big one that you see used for parking garages.
It's about two times this size height and width, so it's 12 inches. 30 centimeters.
We didn't bring one because they're interesting to fly with. They don't look so great in the X-ray, but it's about this big, and it can read a card at about 3 feet or a meter away. I don't have to do imperial here, which is nice. So what you do is you take that and you hide it in a backpack, and you stick a BLE key in it. You need to give it 12 volts for power, but you can buy a 12-volt battery pack or get some lithium cells, connect them together, and plug it in that way. So now you have a totally battery-powered system, and you can walk around, and if you get within 1 meter of somebody and they have a card, it will read it. And once you do that, you can then take the data off, clone the card, and get inside. I've even heard of people doing things for physical penetration testing, like walking into the building and saying, "Oh, I am with IT. We are doing an audit of badges. Could you please scan it on this reader?" And they do. And then you have their card information.
And we didn't come up with this attack. Guys from Bishop Fox released the Tastic RFID Thief. But with the BLE key, you can sit there with push notifications to your cell phone walking around, and you know which cards you've grabbed if you're in an elevator, for example.
Yeah, so it's kind of just the next step of that skimming attack that the people have been doing, but it turns out to be a really great way to get people's credentials and get around buildings. So most of the time where we've spoken to people about this that use these systems and rely on them, they're surprised because they were sold something by a company that does, usually the company selling it is the company that does the installations. They don't really have a security background. They're more like electrical wiring type people. So they just don't know. And we've gotten a lot of that kind of reaction. So Mark's going to go through what you can do if that's your face right now.
Great. So the first tactic, of course, is to enable your tamper detection. And tamper detection is, on most readers, a tiny switch. On the newer readers, it's optical as well, so it'll sense. So you can't defeat the switch as easy by holding it down. It'll sense any light. But of course, if you were tricky, you could figure out ways around that as well. Now, one of the problems with this is we found that most installers, to save money, don't actually run enough physical copper lines to the readers to even hook up a tamper detect. And the second problem with this is that most people don't watch the logs. So the tamper detect is not going to be very useful for you if the computer is sitting, for example, in a cafeteria where I've actually seen an access control computer at a chemical plant before. So definitely take a look at the logs. You should probably even do heuristics. So if you have that capability and you know that Joe comes in every morning at 9 a.m. and uses 3 certain doors, and all of a sudden Joe's card is used at 2 a.m. On a back door that it's never been used on before, that should probably light off an alarm bell somewhere. The other thing, and this is kind of after the fact, is if you're going to use this system and you're really concerned about security, you probably want to have a camera trained on all the doors that you're really concerned about, because you're going to need to do face verification as well to make sure that the person that used the card is actually the person's card in the log as well. And one really interesting thing when we saw in Vegas, because we got invited by the folks at MGM to go back into their key room where they do all of the key rooms for the entire the keys for the entire property, including RFID cards and whatnot, is they've actually chosen to install readers behind the drywall, so you don't even see the reader. You have no indication it's there. It obviously, unless you're going to punch a hole in the wall, you won't get access to the physical wires behind it. So it's an interesting tactic to avoid this type of attack, and even giving someone an indication that there might be something important behind the door there. So I liked that one personally myself. And I should say, these readers do provide some security. We're not saying this is accessible to everyone, although we think that we've made it pretty easy. We think that security that they provide is about the same as a standard key, because you can take a camera like this, take a picture of a key, and make a copy now. And it's about the same with the tools that we talked about and the BLE key. So in closing, I guess I don't have my slide notes up right now, but I think that I just want to say thanks to everyone. It's time to change from Wiegand to some other protocol, and we're really appreciative to be here speaking today.
Yeah, thanks for coming, and thanks to Black Hat for having us. And we have about how long do we have?
Yeah, we got 20 minutes for questions.
20 minutes for questions. We can start. I don't see a hand back there. I'm sorry for shutting whoever that was down.
Yeah, I got a question right here.
When you guys the denial of service,
Yep, denial of service.
to do it the other way around, so lock people in the building?
I suppose most buildings have motion sensors on one side that will activate a remote exit switch, which I believe will circumvent the reader's Wiegand. But I guess theoretically it's possible. Sorry?
It's health and safety risk.
Yes.
Right.
Yeah.
For safety regulations, there typically has to be a override, either motion sensor or physical switch. And this is what you see most often, there's the door handle just opens the door. So that's what you usually see from the inside, because like you said, health and safety, if the building catches fire, you don't want people to be stuck because the reader got disconnected.
That's an interesting question, though. I've never thought of that, that vector.
Over here?
Yeah, I've previously worked at places that use the HID system, but I currently work somewhere that doesn't. But I'm going to guess that other manufacturers have possibly used Wiegand and maybe have similar vulnerabilities. Have you looked at other systems and to get a feel for?
So the first thing, so the question was, there are other companies, and this gentleman's saying he now works at a company that uses something different. So the first thing about these different readers is it turns out a lot of them are actually owned by HID. HID has bought out a lot of people over the last 20 years. So there's a chance that it is actually owned by HID. And
for example, Indala. Indala is a good example of that. They use a similar technology, and they use Wiegand on the back end.
They use Wiegand. So, and companies that aren't HID, there are still some out there using Wiegand. The reason being that the upstream door controller, which we didn't really show, stuck behind here, it's not specific to the readers, that guy. So you can buy readers from one company and a door controller for another, and often they'll work together because it's just Wiegand, and it's just become sort of this accepted standard. There are some more secure solutions, like we were saying, OSDP and Secure Channel Protocol, but we haven't seen any in North America. I'm not sure there's companies doing that here.
Yeah, I've seen some other weird examples, like when you have MyFair, for example, where all of the decision is made on the lock itself. Everything is stored there. They're insecure for other reasons, but that's the other thing, is it's really hard for security professionals to get access to this type of technology. For example, even to get the server software for the back end is difficult. Any of this hardware, this I got on eBay for $200, but it's originally, I think, a $600 controller. And so to get access to the wide variety of stuff that's out there is difficult, and to learn the industry it takes a lot of footwork, legwork, so to speak.
Here?
Yeah, I've got two questions actually. First of all, would it be able to parasite power off basically the door controller lines?
Yes, so the question was, could we just grab power off the door controller lines? We looked at it. So it should theoretically be possible. The issue being, though, that it's pulled up through a 10 kilo ohm resistor. So you'd have to sip power like really carefully. Otherwise, you'd end up pulling the lines low. And after kind of looking at that, we really don't want to make something that you install and then it like breaks that. We wanted to avoid breaking the actual installation. So that's why we ended up going with the battery. Is it possible? Probably if you had some kind of like ultra cap or something and you trickle charged it off the lines, because one line is always high. So as long as you could ride out those transients, it should be possible.
And
It's
12 volts is available to the controller as
Right.
well, but we made a decision not to include that because of potential line noise by pulling it so far down to 3.5,
Yeah,
3.3.
well, that one was, we did look at the 12-volt line for power, but really, in order to make it small enough, that would have been putting a switching regulator inside the reader. And the reader already does some RF stuff at for procs, it's in the 100 kilohertz. So
125.
Or no, it's 25 for, yeah.
125, yeah.
125. So, if you have a 20 kilohertz switching converter with 125 kilohertz card, it could be a bad time.
How would this deal with an anti-passback system? Is that something controlled by the door controller or something you would find on the actual reader?
So the question was about anti-passback.
The ones that I've seen for that, it's typically the door controller programming because the readers are quite dumb. So if you're trying to replay the exact same card right after, that could be an issue. But if you let the thing sit there for a day and collect a whole ream of cards, there is a feature that we didn't demonstrate that's pretty much the replay, but you pass it an argument of how many cards back you want to go. So, if you know you have 100 cards and you just choose back 50 cards, and the passback probably won't help you.
When you send the variable to the BLE, you just select, if you just say TX, it'll send the last one. If you say TX5, it'll send the card number 5 in the list.
Yeah. So it's better, but not totally a solution. Any other comments back here?
You mentioned 26-bit cards. Would it be possible to brute force that feed?
So brute forcing,
First of all, there is an attack using the procs clone and an antenna to brute force. And I think that with the BLE key, we haven't actually implemented it yet, but it'd be a lot faster using direct access to the Wiegand lines, of course. The pulse length is 50 milliseconds, I believe, between each bit. So we haven't experimented with trying to compress it down, but I believe that it would probably work because the controller is not going to care about how much space is, as long as it's running fast enough to read the us pulling it down. So yeah, theoretically, you could probably do a pretty fast brute force. I think for a 26-bit card, if you know a card code and you just want to figure out the facility code, which is not usually printed on the card, it would only take 256 attempts, right? It wouldn't take much. So it's just software.
protection.
And this is, by the way, this is all open source. It's on GitHub. If you add one of us on there, we can, or tweet us or whatever, we'll send it to you, the link. But yeah, you can add that to the firmware, please.
But the really interesting thing with the denial of service would be the case where you have a card code but not the facility code, and that comes up quite a bit. I was in one facility where they had a fire lockbox for keys, which had a glass front on it. And in this fire lockbox was a card with the numbers facing at the glass panel. So you could read the card code by just walking up to their lobby's firebox and looking at the card. So in that case, yeah, 256 tries later and you're in the door. Yep.
Are you also able to intercept the PIN code?
We don't have that in software right now, but we've looked at the pin readers, and it literally just adds some bits. The only issue right now is that we time out. Because we wanted to be able to do it really fast, we time out pretty quickly. You'd have to increase that timeout length.
So on HID procs, that's the case.
Yes.
On ICLASS, the pin is a bit different. So it's done on the actual card. Data is stored there. We have to look into that more. We're not 100% on the ICLASS.
Right. So that's one thing worth mentioning is that ICLASS does have their more secure what's called bio class as well, which is there's fingerprint reader versions. It sounds better. One of the big issues with this, though, is that the actual biometric data is stored on the card. And if you're using the non-elite version, which is using that global leaked key, desk key, somebody could take a card and then encode their own biometric data onto that card, but then change the facility code and the card code. So now they can walk up, use this card. It has a different card code, or it has a fake card code, use their own finger for the fingerprint reader. The verification is done at the reader, and then it sends that over Wiegand back, just the card code back. So those more secure BioClass devices are still vulnerable to faking Wiegand data, and also you can clone the cards, but it's more complex. Yep.
Do you sell?
We are going to do another production run, I
Yeah,
think.
we've had a lot of people asking because they don't want to do it themselves or solder it.
Which is fair.
So we're probably going to make up another 100 and sell it for just around our cost. And we're not interested in making cash or anything off of it. And it is open source. With the KiCad files are in the GitHub repo as well. So if you do want to make it, please.
Some people have, and some people have also emailed saying, I made one and soldering it really sucked. So maybe we should do another run. We'll look into it when we get back to Canada. How about that? You good? Okay.
Well, thanks again,
Great.
everyone.
Thank you.
We really appreciate it.